Hello everyone. So we are at the end of the presentation. I'm Shraddha. Today I'm presenting effect of tree cover on stream surface temperature and raceid habitat using the thermal infrared imaging technique. So as we all are very aware of the consequences of climate change, 2021 was declared as the sixth warmest year by Nation Oceanic NOAS. Uh, the temperature was rise up to 1.2 degrees from the 1850 to 2023. The major factor that contributes to the climate change are rapid urbanization and the anthropogenic pressure that leads to the urban heat island effect, and also this increases the temperature of surrounding areas such as forest, lake, and other water bodies, and that negatively affects the aquatic ecosystem. So why this issue matters? Because the rare side is an endangered fish. So it's an endangered minnow, and we are so lucky that it's located near the GTA area. So 80% of population in Canada located in GTA. There is tiny bit of population found in tributaries of Lake Huron, and the habitat requirement for this fish is cool, clear streams with the deep pools and shallow rocky riffles. This is the only minnow that lives out of the water for the feeding, so that is why it requires cool, clear streams. The major threats to the rare side is climate change and urban expansion that leads to the rising the water stream temperature, and the thermal tolerance of this species is 6 degree in winter and 20 degree in the summer. Other factor that affects the rare side is urban and agriculture discharge, which reduce their visibility to catch the flying insect for the feeding, and the riparian vegetation loss that affects their microhabitat. So as earlier presenter, I already touched upon the point of the role of trees. I would just go through the how the trees can help to reduce the temperature. So trees, earlier studies shows that the trees and vegetation reduce the temperature up to the 11 to 25 degrees through the shading and the evaporation effect. Evaporation alone can reduce up temperature up to the 9 degrees. This research done by Davis 2000 states that tree canopy can reduce the daytime stream surface temperature, and the research done by Young states that tree canopy can absorb 90% of solar radiation. Tree cover can have the approx 2 degrees of cooling effect. So a recent study done by Garner et al. 2014 states that the riparian tree cover had essential cooling effect, and previous studies states that removing riparian tree cover can increase the temperature of water bodies. This leads to a reasonable assumption that increasing riparian vegetation can reduce the stream surface temperature and improve the habitat for the aquatic organisms. There are many various factors that also influence the stream surface temperature, which are the stream depth, width, flow pattern, wind speed, and land use pattern, and tree cover, shade, and tree height, species, and composition. Traditional method versus thermal imaging technique. Traditional method of stream surface temperature measurement was using the thermometer, but it makes it challenging to use those spatial variables. Thermal imaging technique will help to quantify the spatial variation, including land use pattern, morphological features, vegetation, etc., and help to evaluate the stream surface temperature. So our main aim of this study is to assess the effect of tree cover on the stream temperature. So we had two objectives. First one is there any difference between the upstream and downstream temperature, and if so, what intensity? And the second objective was to evaluate the effect of tree foliage and tree cluster length on the downstream temperature. The study area is the TRCA water restoration site, which contains the Rouge River tributaries and streams that provides ideal habitat for the raceid dace. It located near adjoining to Costco Wholesale Mall, Highway 404, Markham, Ontario. So I'm really super excited to share this. Like, we used the high-tech technology of the drone to collect the thermal images. The drone flight was taken up to the 300 to 400 distance from the parallel to the ground, and it was pre-designed to have the overlapping of imaging 60 to 70% of images overlap. The data were collected on 20 July 2021 during the time 11:45 to 12 p.m. and the weather during that time was clear sky with the temperature was 23 to 24 degrees Celsius. So I have developed this thermal map view of drone images using the ArcGIS Pro software. This is the map of water restoration site of TRCA, and you can see that I'm not sure if it's visible that blue line is the stream, which is there, and the part of green is the lower temperature, and the red indicates the higher temperature. So our hypothesis was to increasing tree cover will reduce the stream temperature. This is the hypothesis model. I accept that the upstream temperature will be higher than the downstream temperature, and as the distance from tree cover increases, the downstream temperature gradually increases. Upstream temperature is the before the tree cover, and downstream temperature is the after the tree cover. So the tree cover considered as the 0.0, and for the data sample I selected the criteria, which is tree cluster should have the more than 40% of living tree, and it should be located away from 20-meter distance from each other. In this criteria, I found 10 tree clusters. The temperature measurement was taken for 10 points for upstream and 10 points downstream at 0.5 meter distance increment. The total distance was 5 meters. This is how I collected data in ArcGIS Pro. So this is the tree cluster and the upstream points and downstream points. The flow of stream is in the direction arrow shows. So for the statistical analysis, I used pair t-test to compare the upstream temperature and downstream temperature points at a multiple distance increment, which is 0.5 to 5 meters. I did Cohen t-test to understand the intensity of difference between upstream and downstream temperature, and I did linear regression to understand the interaction of tree cluster length and the live tree ratio with the difference between the upstream and downstream temperature. So this is the results. Upstream temperature, this graph shows the comparison of upstream and downstream temperature of individual tree cluster and the mean of all tree clusters. So the yellow line shows the mean of all tree cluster, and I did the pair t-test, and which says the statistical significant result. However, the Cohen is the lower than 5, which means the intensity is not that extreme. This is the pair t-test at multiple distance for all comparison, and we found some of the statistical significant results at 1 meter and 3 meter, 3.5 meter, 4 meter, and 4.5 meter. And the intensity was higher in the 4.5 meter. So the intensity increased from 3 meter to 4.5 meter, and the Cohen D is the very high in the 4.5 meter distance, which is 0.96. So I did the linear regression, and I didn't found any statistical significant result for any model where I compared the tree cluster length and live tree ratio with the difference between the upstream and downstream temperature. So for the discussion, first, is there any difference between upstream and downstream temperature? So the answer to this question is yes. We found the statistical difference in the when we compared the mean of all tree cluster, and we found some of at the finer scale results. However, we did not find all the finer scale results statistical significant difference, because there are many factors influence the result, which is shading effect of the tree's river with stream flow and tree height and the direction of the tree leaning. There is no visible effect of live tree ratio and the length of tree cover. Our result indicates that the downstream temperature ranges between 23 to 28 degrees Celsius, but the thermal tolerance of roadside is 6 degree in winter and 20 degree in summer, which concludes that even though we have positive result that tree cover have the cooling effect on downstream temperature, but it is not enough for the survival of the roadside species. So here are some of the recommendations. So our analysis only based on smaller scale using the single day data. It would be recommended to have the more seasonal analysis from early spring to the late summer for the better understanding of the effect of tree cover on the stream temperature. We did not incorporate the shading effect of trees, river with the stream flow and land use pattern. In the further study of this research, it is recommended to incorporate those variables. Other than that, the planting taller tree species which have a higher shading effect, as earlier studies mentioned that. So it would be great that for the restoration of this project, TIA should include the planting taller tree species and the creation of habitat patches with the less canopy gap would be recommended for the further support to this research and for the habitat restoration project. Also, extensive tree inventory is recommended for the Toronto Regional Conservation Authority to include and for support this research and to evaluate the health status of tree. I only found 10 tree cluster within the criteria, which is the 40% of living trees. So I think even though we have the tree cover, it's not enough for the roadside survival of the roadside species. Then I would like to acknowledge Professor Patrick James for his supervision throughout the project. Dr. Jonas Hamburg will help me throughout the internship and the project. And Dr. Jonas, who was senior scientist of TRCA, for his valuable insight, and the last MFC class and cohort for their encouragement and support.
Thank you, Shraddha. I'll ask Jonas to ask the first question. You on the line?
Yeah, I'm here. Can you hear me?
Yes, thanks. Go ahead.
Great. Good job, Shraddha. This looks great. Happy to see the results. I would like you, so my question would be, you said that the temperature tolerance, the upper temperature tolerance of roadside dace is 20 degrees Celsius, and that the measurements we had were between 23 and 28 degrees. Could you reflect on, and this is a stream that does have roadside dace, could you reflect on why you think they could still survive in this stream?
Actually, I don't know. I didn't dig much into that research, but I think because of the as roadside days Even they laid their eggs in 19, but we only have collected data only for one day, which is the temperature. If we have the seasonal variation of other data, we might have the different result what we got in downstream temperature, which is 23 to 28, like early spring. And I don't, so that is why maybe the race side is still exist.
Yeah, I think that's a good, that's, I think, a good, like, one reason, as you pointed out. I would also consider, stream depth, and that what we see with the thermal camera is only the unshaded areas. So the shade, they might hang out more in the shaded under the trees during sort of hot days, hot sunny days. Yeah, that was my question.
Thank you. Patrick?
Hi, Shraddha, nice work. So you mentioned lots of other factors that could be influencing the upstream and downstream surface temperature. And it was interesting that we were able to see an effect, but weren't able to assign any particular factor given the things we looked at, right? Like crown depth or the run of the river that was covered by the tree. What other things do you think you would prioritize in measuring to maybe explore that in more detail? What other attributes of the stream would you like to include if you say were to do this project again?
I would like to include the shading effect of trees, because earlier researchers indicates that more of the tree have more shading effect, has greater impact in the reduction of temperature than just the tree canopy. So I would say to include the shading effect of trees, and also that during my measurement, as I mentioned, different tree clusters. So for the tree cluster 4, I guess I found that the river depth was higher, and that is why I see the result which has very great difference. So I would say river width also we should include in to incorporate this in the research.
Yeah, that makes sense. I guess the only thing I was wondering about, and I don't think we had talked about this before, was there any other input into the streams from other small streams or creeks that went into the water that could also influence the temperature? Or did you control for that with your site selection?
There are some outlets, water outlets, and we didn't measure those water outlets in our analysis. We should include that. And also the stream is flowing in 2 directions. It divides into 2 directions, west and east. So we can compare the way how the temperature difference from the west side of the stream and the east side of the stream.
Thank you.
Great. Any questions here from anyone in the audience? No? Any virtual questions? Okay. Well, thank you so. Sorry? Oh. Oh, and you thought it was a question. Oh, okay. Justin, do you want to unmute yourself?
Yeah, sure. Yeah, I was just wondering, first, can you define thermal tolerance as you use it in your work?
The thermal tolerance of the siders?
Yeah, like you were talking a little bit about thermal tolerance in the beginning, and I was just wondering if you could define it. I might have missed it, so.
So I found that in the research done by the novel 2000, in that he mentioned the thermal tolerance means the rayside days can survive in the winter up to the temperature is 6, and in the summer rayside days can survive when the temperature is 20.
Okay, perfect. So it's just bounded around survival. So that leads into my second question kind of nicely. So there's some studies in the USA, like looking at red side dace critical thermal maximum temperatures, which are much higher than you noted in your study and kind of what Jonas was talking about as well, right? So in some studies, it's in Ohio or New York or something, I can't remember, we see critical thermal max temperatures above 30 degrees Celsius in the summer. And so I was just wondering, like, is there phenotypic plasticity in this species? Like what's enabling their survival at much higher temperatures somewhere else?
Critical CT max is the different than thermal tolerance, I would say. So the CT max is the highest point where the ray side is can survive. It is the limit, but the thermal tolerance is around 6 to 20 degrees.
Okay, so thermal tolerance isn't lethal then, right? Is that what I'm
Yeah.
getting at? Okay, perfect. Thanks.
Interesting. Okay. Thank you so much, Shraddha. All right. So,
Can I
oh,
just
sorry. Yes.
just a tiny comment to Justin as well. I think Shraddha did, at least in an earlier draft of her paper, did bring in another paper that was showing these higher sort of maximum critical temperatures where the red side dace would like literally start sort of floating, would stop swimming, which is, I guess, these higher temperatures. So I'm assuming these other tolerance numbers that Shraddha is showing, the lower ones, are more about, I guess, continuous survival. I haven't read that paper, but must be something like that, or like reproductive limits or something.
Yeah, certain. Yeah, I was going to say with reproductive.
Longer term or something. Yeah.
Yeah. Okay, great. Oh, awesome. Thanks.
Great. Thanks for a great discussion. So that